Let's model another one. So remember, the N is the box, -6 are my red counters that are over here on the left-hand side, and my yellow counters are on the other side. They represent the equals 3. Our goal is to get the box by itself. So that means that I need to get these out of here. So what I'm going to do is use my zero principle to make them equal 0. So what I have to do is take a +1 for every one of the red ones. And every time I put a plus on this side, I have to put a plus on the other side. So I put another plus to go with that one, and I put a plus on this side. I put a plus on this side. I put a plus on the right. Left, right, left, right, left, right. So what I did was I added 6. So I'm going to show you that what I did was I added 6 to the left-hand side of the equal sign, and I had to add 6 to the other side as well. Now, on my left side, this one cancels out that one. They all cancel out, positive and a negative, to make 0. So I can now delete all of those because they made 0. That means that on my left side, I'm just left with N. And on my right side, I don't have any negatives, so I can't get rid of anything. I have 9 positives. So my answer is N equals 9. And if you were to substitute that back into your question, if you put a 9 in where N is, you have 9 minus 6. Yes, that does equal 3. So we know that we are right. Let's try this one. This one's a little bit different because now I have 2 times n, so that means I have 2 n's, and that's why I have 2 boxes on the left, is equal to 12. So we're going to do this differently. What I'm going to do is, because I have 2 n's, I'm going to separate these into 2 separate piles. So that means each one of these n's is equal to a pile. That says then that I can get rid of one of these guys and one of these because it's the same. So what I did is I divided both sides by 2. And this is how we show that we're dividing both sides by 2. And my answer then is n equals, and you can see here on the right-hand side, that n must be equal to 6. I'm going to do one more. This time it says a number divided by 3 is equal to 4. So what I've done to set this up is I've made sets of 3, and I have to make 4 of them. So if I have 4 sets of 3, it's kind of hard to see this, but now this is n is equal to how many? That would be 12. We're looking for how many groups of 3 fit into the unknown number, and there has to be 4. So see how there's 4 groups of 3, and this answer then is n equals 12. It might be easier in this case to look at this as we're going to do the opposite operation to get rid of this divide by 3. The opposite to divide is multiply. So if I multiply both sides by 3, and I multiply this side by 3, then you can see, oh, right-hand side is equal to 12, and the left-hand side, I'm multiplying by 3 and dividing by 3. And because those are operations that are opposite, they cancel each other out, and I'm just left with n equals 12.